you saw my previous video about refurbishing a BBC Micro, you'll recall that I mentioned that I have another one to look at, this one being a little more special than the average beep. In 1991 and 2, a company called Software Bargains started to advertise BBC Micros for sale, as you can see here. And they're marketed as unused high specification, so effectively new, and they continued to sell these for some time. At first there were adverts that included the BBC Micros as a feature in amongst other products, mostly software, and of course down here you see even the Archimedes computer is being sold alongside, and in some cases they advertised just for those computers. And what the advert explains is that these computers have been modified from the US spec. Now what happened here was that Acorn tried to make a push into the US market, and unfortunately, due to, well, a number of things, I think mostly the problem was that they already had traction with other brands in the US, and without the backing of the BBC name being such a big thing as it was in this country, they didn't sell. So they were shipped back here, modified back to US spec, and then sold as new or nearly new. And that's what this computer is. And I have a similar job to do as I had with my own previous one, which was to fix it up, refurbish, clean it, but also I have some new information about this computer which I'll share with you as I go on. And there you have it, one rather mucky BBC Micro. Now at first sight these things look like any other BBC Micro, with the exception of the weight. They weigh so much more than a normal beep. There has to be something going on inside that's different. And if you had a new one and you turned it upside down, you'd notice that you couldn't get to any of the ports underneath because there was a big sheet of metal in the way, which you had to unbolt to get into these connectors. And the similar thing happened inside as well. I'll take the lid off in a moment, but there was another big piece of metal stopping you getting to important things like the ROM sockets. So in order to be useful, both those pieces of metal had to be removed, and inevitably you never put them back on again and they got lost. As is the case with mine. I removed those pieces of metal. I remember doing it, putting oddly shaped pieces of metal on a shelf is always a bad idea because they drift and in the end they disappear forever. I can see I've left some of the screws out of this, which I will remedy as I work. So, what you immediately notice is that the ROMs are here. So remember, on the original BBC Micro, they were just out of reach under the keyboard. And if you've seen a B+, you will find them over here. This model has them in a different position again. In fact, it's a completely different circuit board layout, not just the layout itself, but also the identifiers of the components, and in some cases some of the circuitry is completely different. Ostensibly it's still a Model B, but there are some important differences which I'll get to. Now, if you bought one of these when they were still in print, you'll remember that inside the back cover there was a piece of paper which is the complete BBC Micro schematic. The only problem is this isn't really a standard BBC micro. And when it comes to the schematic, it's so radically different that it's not easy to follow anything with this. I mean, yeah, sure, some of it's wired the same way, some of it isn't, and everything's labelled differently. So what do we do about that? Well, the usual thing to do would be to go online and search for the correct schematic. And unfortunately, there really isn't much information about this model available at all, and so many years have gone by that I don't think that's going to turn up. So if you want to know anything about this, you really have to work it out for yourself. And after a discussion on Stardot about the ROMs, I realised that there was something different about the ROM circuit. I decided at first just to probe out the full ROM circuit and see what was going on. But you know how it is. Work expands to fill the time available, and in the pandemic there was an awful lot of that. So I kept going. And I ended up going far further than I ever intended. And I now have the complete schematic. I took version 4, which is the one from the Advanced User Guide, what you're looking at here, and updated it as far as I could based on all the other versions that came after it. And then from there I added my own modifications based on what I was seeing as I probed through the board. Quite a job, but again, plenty of time. So what we now have is a proper circuit diagram for the export one. Now, this is the UK modified version because I don't have access to the original one. But as I understand it, the original US one would have had a different UHF modulator here, a different speech PHROM here, and a different operating system. And I'm sure there were a few other tweaks, but nothing particularly complicated. So this is very close to the US version as supplied, and of course the German version, because this was the same layout for that version too. So I'm going to go through what I found and explain the differences between the B and the USB. Don't hold your breath, the real differences are only in the ROM circuit, but I'll go through it all just so that you know what's what. So I'm going to start on the top left. We'll use the original B schematic so that you can see what changed. Okay, up here you'll notice that a new resistor has been added and a link. When you close this link, you're going to change the value of this resistor and therefore the timing of this circuit. This is connected with the read data input, and I guess it's some kind of compatibility modification. A little lower down there's another one which again looks like perhaps a compatibility change. A new link here has made this connection an option, either to QA or to QB, whereas previously it was on QB. Timing changes for the floppy drive. Next, printer. All laid out the same way, except on the original one there's a transistor and an option, and that's used to decide whether you want to invert the strobe signal, which comes out there. Now over here the transistor's gone, they've put an inverter in its place, but there's no option, so basically it's going to be inverting all the time. That's the only mod to the printer port. Here, there's a variable resistor, and that's used to adjust the volume of the sound out of the speaker. And something odd's happened here, because on my board there's a capacitor there. So they've turned it into a filter with no adjustable pot. Over on the speech processor, right, where am I going? There we go. So here we have an adjustment for the clock rate on the speech processor. You saw me adjusting that in the last video. So on the original one, there's a parallel resistor and a pot, and on the new one that resistor's become serial. I don't know what difference that makes. It may be for clock stability, it may change the noise, maybe, I don't know. But it's nothing to worry about. Okay, now looking at the clock circuit. So over here we have an OR gate and an inverter, and here we have a NAND gate and no inverter. And generally speaking that's the same thing, but there is a flip-flop circuit here connected to it. I'm not 100% sure that it's doing the same thing, but I'm making that assumption. Okay, let's find the 6502. Where are you? Here we go. Okay, so you see pin 38 on here is pulled up to 5 volts via a resistor, and on the new one there's no resistor, it's just connected short straight to 5. Again, it's probably not very important. Now here's the data latch, which is fed from this NAND gate here. Over on the new one we find that there's an additional bit of circuitry being inserted, and as far as I can see it's tying it in with a 16 meg clock signal, so it means you will only get data being latched in sync with the edges on the 16 meg clock, whereas before you didn't. So it looks like some sort of clock tidy up circuit. Well, we know it worked fine on the old one. Maybe it was marginal, but there you are, that's what's changed. Now on the startup circuit, here we go, here's the reset, 555 timer. You'll see that there's a reset switch shown here. Of course we don't have a reset switch on the Beeb. There is a hole in the back of the machine, as I've previously pointed out, where you could mount one if you really wanted. On the new version, that is the US version, where the reset switch pads are is actually an audio socket set of pads, but there's no hole in the back of the case to fit a socket, but it is there in exactly the place that I put my own audio socket in the original one, ironically. So this reset switch has been removed from the circuit, and there appears to be an extra capacitor in there as well. Of course what you don't see in the circuit diagram is where these capacitors are physically placed, so it could be that this has been added simply for noise immunity somewhere in the circuit. Okay, over to the RAM. I always struggle to get my bearings with the RAM. There we go. So, on the Model B there is a link S25, and that's there because in some versions of the B you used to only have 16K in the Model A, and this link selected between 16K and 32K, and it's become quite a useful debugging tool because you can switch that over to 16K if your 32K RAM is playing up, and with a bit of playing about you can even reverse which half of the RAM is in use. Well, unfortunately for the debuggers, that link's not present in the US model, simply because there was never a 16K version of this produced. Okay, video processor. Going to have to zoom out on this one in a minute. So, generally speaking, things are often a little different around this chip because there were a number of different versions of them and there were different components and component values fitted depending on the version you had. So on my version, my US version, these diodes, which look as though they're creating some kind of reference voltage, are not fitted. Now they are showing up on the schematic for the standard B. And here there's a link setting which can switch you between 0 and 5 volts. And I remember trying this on my Model B years ago, and it does indeed invert the picture. But on the US version there's no link fitted at all either way, but there is a wire modification, and it runs here, connects to this TTX VDU signal. Now I suspect that modification might be needed even on a standard Model B depending on which version of this chip is in there. So I've drawn it in despite the fact that it's a wire mod because it's there, but that's all about there is to say about that. Except of course to add that the link on S26 should never be fitted in either side because you'll be shorting out the logic gate that the other end of that wire mod is connected to. Okay, over to the cassette circuit. It's up here. This one is not too unusual, and in fact this change is present on other versions of the BBC Micro, like the Master for example. So here's your input from the cassette, and it passes straight into the amplifier. And on the US version there are two diodes. These are connected to the power rails in such a way that if the input signal goes above 5 or below -5, they'll go to a short and dump the current into this resistor. So you're effectively having it clamped to ±5 and protecting this circuit from being overloaded. I've even seen a note for the service personnel telling them that if they see this same problem being repeatedly happening, that this chip was being damaged from the same computer, to actually make a modification internally to put these in to protect the circuit. That's the only change to the cassette circuit. Okay. Oh yes, we're now down in the video section. So this section entitled Burst Gate, originally there was an inverter here, not present on the US model, but we do have a flip-flop, and as far as I can see it's configured to act like an inverter, so it may just be a case that they used that thing for something else, for example the printer port, and then they had to go and find something else that would do that job, and there was a spare flip-flop. So I don't think the intention here is to change any functionality at all. What else has changed? Ah yes, there is a filter here, resistor and a capacitor, not present over on this side, and it's across the power rails in the video circuit, so I think it's there just to try and smooth out any noise that might appear on the 5-volt rail. There's also a new link, S38, not present here, and that will disconnect the colour burst from the UHF modulator and coincidentally from the video out. And I know we already have a link there to do that for the video out. This one will make the modulator output black and white as well. Again, not sure what the requirement was there, but that's what it is. And while I'm talking about the modulator, we've of course replaced the US one with a UK one. And on the US one there was a pin called LS, and this little circuit where you can either switch that signal to ground or to a capacitor to ground. I've no idea what it was supposed to do, but it doesn't have any effect when you've got the UK model because that wire isn't actually connected And finally, the video out composite has an inductor added. See, not present here. And other than those things, there's no change to the video circuit at all. So if any NTSC work was done, it was probably going on by reprogramming the registers in the driving ICs. So that, apart from the ROM circuit, is all that changed. Now the ROMs are going to take a little bit better explanation. Okay, I think I'm going to describe the BBC-B first, and then I can explain, you maybe understand what I'm talking about when I start talking about the changes over there. So, firstly we have a couple of bits of address decoding going on, and this will provide the enable signal to each of the ROMs when you're talking in the address range required. So they all go active when you're talking in the correct address range. And here we're doing some decoding to find out when we're talking to specific peripherals like the tube connector, the ADC, floppy disks, vias and so on. And also via these link options here, whether we're talking to ROMs. Because there was a time when you could have very slow ROMs in here and you needed something to be done about talking to them. Everything on this logic gate here is an option to slow down the clock circuit to the micro here. So if any of these inputs go active, you'll cause it to slow down for that period. Let me come back to how that's changed on the new one in a moment. So how do you get from the ROM number that you write out to the hardware to an active sideways ROM? Well, your ROM number comes in here and sits in this latch. And there are some link options, and they're already well enough explained, so I won't go into detail about what the options are here. But basically your two bottom bits from your 4-bit value end up in this demultiplexer, and 2 of the bits are not used, so you've only got, having 2 bits means you've only got 4 possible ROMs, and that's these 4 here. And they get demultiplexed here, and each one of these drives the chip select signal on each IC, and that's how you get your individual ROM selected. There's a separate one here that works with the operating system because it's a different address range, and that decoding's done here. The 2 unused bits, well, they're pulled up to 5 volts and basically just kept out of the way. If you wanted to work with more ROMs, you had to tap in some wires to those 2 pins there, and you'll see that modification going on with most of the sideways ROM upgrade boards. Okay, well that wasn't too painful, but something I did want to point out, if I come back to these here, when you look at the new circuit, you'll notice that those ROM slowdown lines are not there, and that's because by this point no one was using slow ROMs, so we didn't need them. So they've removed the options and left these pins open. Yes, you heard me right, they've left them open. This is unusual. Let me explain. Up here we have these 2 signals, Jim and Fred, which have been created out of the address decoding, and each one of them goes to one of the inputs on this logic gate. Now in this circuit the Jim and Fred have been ANDed together, so we've got a combined signal, so we only need one, and the other one's not used. But look, the not used pin has been pulled to 5 volts, and that's the way you should do it, because if this pin was to float low it would activate this circuit. Now I know that logic gates 74 series tend to float high when they're left open, but I measured this on a scope and I found it sitting at 1.2 volts. The switching threshold for TTL being 0.8, that means we've only got 0.4 volts of headroom and a bit of noise might take all that away as well. So I'm a bit bothered that on some machines this might float low and cause some very weird effects. I tried pulling these up with weak pull-up resistors and they went straight up to 5 volts no trouble. And I suspect what's happened here is that there was an error in the circuit board layout, and these were intended to be connected straight to the 5 volt track, which would have been under the IC, and they've missed it. So something to look out for. Pull these up to 5 volts if you're seeing problems with that. Now what else is going on here? Well, these ICs are all 16K, or I should say the addressability of the sockets is for 16K. You might see the word 2764 and 27128 described there, but the truth is that was just describing what chips were in use at the time. So you can put a 16K ROM in each of these, and for the 4 sideways ROMs you can have 1 sideways ROM image in each IC. You can't take 2 8K ROM images, bung them together in a 16K ROM, plug them in and expect them to work. No, it will only start the first one, not both of them. And that's because when you decode here, you've only got one output selecting the IC for each of the different ROM numbers that you've sent to the latch. Now over here the story is a bit different. Firstly, they've connected A14 via these links, which means that you can get a 32K IC, a 27256, in each of these sockets. There are some gotchas here, I'll explain them as we go. This last one doesn't have A14, so it can only take a 16K device. Reason for that in a moment. This one can take a 27256 device, but it can only have one ROM image in it because of something else I'll explain momentarily. These two can both take 2 ROM images and be activated properly. Now the operating system ROM has also got the ability to take a 32K chip. You must put the OS ROM at the top, and you can put anything else you like at the bottom. The sensible thing to do is put BASIC in there. Now on the B, these were delivered with the OS in this socket and BASIC here, and what most users did was pull this one out and move it up to the top. The reason being that there's a priority here, and the top priority goes into the rightmost socket, and you wanted BASIC to start when you powered the machine on, so move it to there and put different ROMs in these 3. Well, of course if you put BASIC in this chip you're kind of stuck, because you can't move it over to there because it's in that chip. So there's a link here which can be optionally changed, and it changes the priority of these 2 sockets, swapping the lower half of that one with that one, and that's why this one is only a 16K addressable. It's part of that priority mechanism. So my advice is make this so that the BASIC ROM appears in the top slot but actually physically lives in this chip, and that will then be, well, a sensible way to go. So what else is going on here? Well, here's your latch, and there are 2 demultiplexers. This top one is driving 2 of the ROMs, but because we're putting the top 2 bits in here, there are multiple values of ROM number that will send an activation signal to these ICs, and that's how you end up with more than one available ROM inside the chip. You can only do 2 though. I mean, at first sight you might think you could have 4 in each one, maybe 4 8K ROMs in a 32K. No, you can't, because of the way the addressing is done. You can only address at certain address boundaries, so you would work with 8000 for the first ROM and C000 for the second. Down here we're decoding firstly for this IC and secondly we're decoding for, well, that one or the bottom half of that one, depending on which way these links are set. And the issue with this chip is because it's being decoded from this demultiplexer, you're only getting one signal to enable the chip select on here. You're missing a second chip select. So what appears to be going wrong here is you've only got the even chip select and you need the odd one, and strangely enough there's a spare odd output here connected to nothing. And I had a theory that if you were able to combine that output number 1 with number 2, then that might be enough to get you full functionality here, just like these two ICs. And I made that modification and proved that I'm right. You'll see that in the video to follow. The upshot of doing that is that you upset this one. This switch here, I don't really understand why you would want this, but it appears to be optioning these two ICs so that you can put a single sideways ROM image in two 8K ICs and plug them into these two sockets and it will somehow run it. I don't see the point, unless I missed something and it's doing something else. But if you make a modification here to combine 1 with 2, you'll foul up what that's doing, and basically you just need to leave that where it started. So I think I've said enough and bored you enough. I've explained as much as I've managed to gain from this. My advice is set these so that they can all take 32K ROMs. Make yourself a ROM with OS and BASIC in, and option this so that BASIC appears in the top slot, and you'll have, well, effectively an upgrade for free. Just for completeness, here's the modification I'm suggesting to get you the fix to this IC. Your wire OR-ing, diode OR-ing the two pins together. Don't be tempted to short them, that would be bad. This is being done in exactly the same way as the ROM signals were done on the original B, with a pull-up resistor and diodes. And that's all there is to it. Well, except that I've also got a spreadsheet. Now this thing came out of the documentation that I was generating as I was making the new schematic. So it's a cross-reference. Firstly, in the first column you've got the IC number on the new board and the equivalent IC number on the BBCB. Now because they have rewired the board, not every gate in every IC is doing the same purpose it used to, so it's not a one-to-one match, but it's good enough. Name of the component, description of where it is or what it's doing, and I also have an XY reference onto the schematic. You'll notice the schematics have these numbers at the top. And also a reference onto the PCB so that you know where the component is. And I've also included some photos. Let's bring that over. Okay, and I've put some rulers aside so you can basically find physically where those components are, because they're not always in the most sensible places. The audio circuit appears to be half on one end of the board and half on the other. Pay no attention to the contents of these ROMs. These were simply experimental ROMs that I downloaded from the archives just to test out my theories. So further down the spreadsheet, of course we go through all the components, resistors, capacitors, diodes and so on. I also have a table of links and what they do, where they are. And finally a list of those differences. That's the list that I've just been going through. And that's it, that's my information drop. And now we're in a position to debug these things properly. Now all the files I've just been describing are available for download from my website. See the link in the description below. I'm also going to go to Stardot, to the 8-bit Acorn hardware forum, and put a post on there, and I'll try to add zip files containing the same info. Hope you found this useful and not too boring. We'll get back to the refurb in the next video.